Hello everybody, it's Uncle Mike with my Kerbal Kareer on Kerbal Space Program, the Xbox One Enhanced Edition. And here for Mission 18, we are going to do our first training. And the topic of our training is thrust to weight ratio, or TWR. I am playing on the Xbox One Enhanced Edition, so we do not have the data provided to us for many of our parameters that we need for our design of our vehicles, and also our orbits, our orbital transfers, our maneuvers, and so on. So we have to calculate those here on the Xbox One. So I decided that for some of my missions here of my Kerbal Kareer, I will then take time to do some training of these topics. And so the topic today is thrust to weight ratio, or TWR. So let's go ahead and get right into the VAB, and let's build a simple vehicle that we can then do some training on with thrust to weight ratio, or again, TWR. So I am going to make a unpiloted vehicle. And it's going to be very similar to other vehicles, basic vehicles that I do. It's going to be a probe design, but it'll have a place for a capsule maybe in future training missions. Let's go ahead and put a docking port up here, because we might want to eventually in training do some docking training and so on. That way we just have a vehicle already set up for this. So let's go ahead and put two drogue chutes on. There. Go ahead and put our main chutes on. Let's also go ahead and, just for preparation, let's go ahead and put on a docking light just so we have it. Something like that. How did I get that like that? I have no idea how I did that, but it was pretty interesting how I did. So let's do it. Let's rotate this around. That. Now let's go ahead and move it in. You can see with the Xbox One, it's a version, it's a little more difficult to move these parts around. So something like that, perhaps. Let's go ahead and rotate this. So much work just to get a light. All right, so there we go. So now we've got our docking light for future missions. We're also going to go ahead and put some level of payload. We probably don't need it for this flight, but we are just going to go ahead and put it on. Now we'll go ahead and we will build. And again, we're just building here a training vehicle. Not even sure what the name will be, but maybe we'll call it something like training vehicle. So there, in case we want some science or whatever, but there's basically our basic vehicle, except for this is can be unpiloted. It can be remotely piloted. So let's go ahead and put some antenna. And let's go ahead and like that with the antenna. There we go. I like that for re-entry. So we got our heat shield. We got a payload bay here for future. Let's go ahead and start to rename this. So this will be, let's call this the training TV1, TV Mark 1 for training vehicles. So this is the TV1. Let's save that. So here is our capsule, our basic capsule. Right there. There she is. And so we've already saved this, I think once. There we go. We saved it. Now let's press the X button to pin that. Oops, sorry, press the A button to pin that. And you can see that we have a mass of 1.735 metric tons. This is mass. So let's go ahead now and let's get this vehicle where it really starts to look like a rocket. Go ahead and put on one fuel tank. So now this is 6.235 tons. And because we want a safety factor in our designs, what I do is I just round. Typically, I try to round up. So I'm going to say this has a mass of 7 tons. Now, of course, once I put an engine on this, and so if I put a Terrier on here, you can see now we're even closer to 7 tons. But this is 7 tons of mass. To calculate this into a weight, well, weight is mass times gravity, and gravity is 9.81, just like it is on Earth. But I'm going to say 10, again, just for a safety factor. So my weight, or excuse me, my weight and my mass will be higher than it really is. So it just gives me a safety factor. So this is not 6.7 tons. It is 6.7 tons of mass, or 7 tons, we'll just round it up, 7 tons of mass, but multiply it by 9.8 or multiply it by 10, rounding up 9.8, it gives us then that if we're going to say this is a mass of 7 and gravity is 10, we now have a weight of 70. And so now if I look at the information here for the Terrier, the thrust at sea level of the Terrier is not even 15 kilonewtons. So because of that, the way to look at this is, therefore, if we have a 70 Newton now weight component, and remember this is in tons, so, but it's 70, just don't worry about the units, just do the math and then don't worry about the units. So if we take our mass, which we said is 7, rounding up the 6.35 to 7, multiply it by gravity, which is 10, so that gives us 70. You can see that the Terrier only has, we're trying to find something that's got 70. Well, the Terrier doesn't even have 15. So this is not going to even get us off the launch pad. And we can confirm that because why? Well, we can go ahead and take this out to the launch pad. So it's as simple as taking the mass that it gives us, the numerical value of the mass, times gravity, which is 10, and then compare it to the sea level thrust. Now, of course, if you're in space, then you would want to use the vacuum thrust. But we're trying to get off the launch pad. So staging looks good. We're not even going to leave the launch pad. Throttle is set, so we're go. SAS is active and go. So we are T-minus 5, 4, 3, 2, 1, and ignition. And you can see that full throttle with the Terrier, we're not even moving. So engine, cut off the engine. Let's go ahead and recover the vehicle. So again, we're taking the mass, the numerical value of the mass that the engineer report gives us, multiply it by 10. That then gives you the weight or the force of gravity on your vehicle. Then you can look for a comparable engine to overcome that weight or that force of your vehicle. So what I'm going to do is I'm going to take off the Terrier. And now what I'm going to do is I'm going to come in here. I'm going to look at, okay, Terrier, I've got the swivel. The swivel has 160, almost 168 thrust here at sea level. So I am going to put that on there. So 168. If I now pin we now have a mass of 7. We're going to call that 8 times 10 is 80. And the swivel has 167. So the swivel here has got 2 times the thrust of what I need. I only need a little more than half of the swivel's thrust. So what I'm going to do is I can come in here by pressing X on the swivel, and I'm going to go ahead and knock it down to about 60, right there, about 60% of the thrust. Now, when we fly this vehicle now, even though the engine is heavier, but it's got more thrust at sea level, So now this is actually going to be a flight. So I'm going to go ahead and I'm going to redo my staging because I want to make sure that I put my drogue chutes, because we're going to actually now be flying this vehicle. So we're going to be ready for launch. So staging is go, throttle is full and go, SAS is active and go, flight we are go. 5, 4, 3, 2, 1, ignition. And now you can see that even though I have basically de-thrusted, right, reduced the thrust, limited the thrust of my swivel, I now have a vehicle that has a thrust to weight ratio that is greater than 1. So it will lift my vehicle off the launch pad. Now, based on the amount of fuel that your vehicle now has and its consumption of fuel, is then your change of velocity, which is something that we will look at in a, in a future mission here when we do some more training. So as you can see now, I've got this nice swivel and we're flying it out. We're about halfway through our fuel. And of course, because we are burning fuel as we are going up, our thrust to weight ratio is then actually also increasing, meaning we have more thrust than weight because we're losing mass of our fuel. So I'm just flying this vehicle up here. We're passing 12 kilometers in altitude, 500 meters per second. We're pushing 2 G's of acceleration, so we're getting fast. We're accelerating at a greater rate as we burn mass because our thrust to weight ratio then is increasing. Because our mass, therefore our weight, is getting less. Plus we are getting farther away from the gravitational center of Kerbal, so the gravity is reducing there also. So we're about to go with MECO. Let's go with separation. Oh, I did I did not put a separator on here. So there is no separation. Again, we are not flying with a Kerbal inside, so let's go ahead and let this thing just fly here. We'll go into 4x time and just let it, look at that, 50 kilometers in altitude. Yep, looks like we're about 51 kilometers. So we need to, on the next, we need to add a decoupler when we go to the next stage, which is what we're going to do is we're going to add more fuel. Which means since we are going to add more fuel, we'll need to also then change the thrust limiter to 100 on our swivel because we will not have enough thrust because we limited the thrust. So we'll see if this survives. It is we'll just lose some funds. Nope, it's going to flip around on us here, so that's good. Should survive the heat here. It's not going to get super hot. So, but it was a little bit of an error there, not putting a decoupler in. Let's go to the drogues. Drogues might get a little damaged here. Alright, very nice. Let's go ahead and bring this down before we go ahead and pop out the mains. Looking good here. Go ahead and get the mains out. Very nice. So that way we can at least recover our vehicle here. So, and there we go. All right, let's recover the vehicle. We got to make that change so we have a decoupler. But now what we're going to do is we're going to do what we've just learned and calculate the thrust to weight ratio by adding another fuel tank and changing the thrust limiter back to 100 and see if the swivel then can also get us off the launch pad here at Kerbal. So we're going to add some weight by adding a decoupler. So here is our vehicle. So let's go ahead and take that off. Let's add now a decoupler so that way we know that everything will survive. So, whoop, wrong decoupler there. That on there. There's our decoupler. So I like to limit the decoupler down to about 10% or so. It just makes a more realistic separation. So now what we're going to do is we are going to add a second TL800. Get that on there. So there's our second 800. And now what we'll do is we'll come down here, we'll grab our swivel, and we'll our swivel on here, remembering that our swivel, if we come up here to its information, at sea level, our swivel makes 160, roughly 160, we'll just say it, thrust at sea level. Our vehicle right now weighs 12 mass tons, so multiply that times 10, so that'd be 122. The swivel makes 167, so 122, so we are okay, but we just need to raise that back up to 100. So now this is producing 160 units of force, and our weight is 120 or 122 units of weight, or 12 units of mass. And again, to get from mass to weight, we just multiply by 10, multiply by gravity. So I'm expecting this to launch not with as great of an acceleration, but it will launch just fine. And now that we're carrying more fuel, we will be going higher. We'll probably be able to go into space with this vehicle. So that is how in the Xbox One Enhanced Edition, you can get the information to very quickly decide if you are going to have a vehicle that is actually going to be able to get off the launch pad. So staging, I need to now fix my staging, which I should have done in the VAB, but we'll fix it out here. That's why we do a pre-flight check of our staging. So everything's looking good there. All right, so staging is go. Throttle is full and go. SAS is active and go. Flight, we are go. So T-minus 5, 4, 3, 2, 1, ignition. And as you can see, we do not have, as even now we have full thrust, we've added more mass, therefore more weight. So our thrust to weight ratio is still greater than 1, which will get us off the launch pad, but we're not accelerating as fast. And of course, our acceleration will increase as we burn more mass, meaning we burn fuel. We're passing through 100 meters per second. We'll go ahead and continue this flight as normal. So I'm starting my pitch program to the east so we can just do a nice ballistic flight here. I'm going to fly the bottom half there of that velocity vector. That way I just continually arch over here as we head toward space. So 6 kilometers in altitude, 315 meters per second. Passing through max Q, so we're getting some weird aerodynamics on the vehicle. Pass through max Q. Line it with the swivels gimbal there. There we go. Got through max Q. Stay 090 on the heading and just continue to fly a nice arc to space. I am not going to throttle back like I normally would, so I'm just going to go ahead and keep flying this. 19 kilometers in altitude. We're accelerating to 4 G's of acceleration. The reason being is because we are burning mass, we're burning fuel as we go, so our thrust to weight ratio is actually increasing. I'm just going to go ahead and let this fly, heat up. That's why normally I would be backing off the throttle, but for our experiment here and our test, I'm going to go ahead, and now that we're passing through 30 kilometers, 37 kilometers, I'm going to go ahead and keep pitching over here. We're going to let this just get some more horizontal velocity. So there we go, and now we're just going to go to MECO. There we go. Let's go ahead and now separate. There we go. Much, much better in terms of our separation there. That's actually a really nice shot. I like that shot right there. That's cool right there. Haha. But we are in my Kerbal Kareer on the Xbox One Enhanced Edition. So to do this training, I am burning some fuel here and burning some money. So there we go. So now we're out into space, so you can see that even that vehicle gets us to space. A very simple design here. Let's go ahead and go all the way up to apoapsis at what, 200, about 230 kilometers. Come back in here. We will lose should lose our time warp when we hit, yep. go. So now we're hitting the atmosphere. Let's go ahead and get into retrograde. Now we can go ahead and go through reentry. All right, let's go ahead and come in. We're in the plasma here, so I cannot control the vehicle. We are in the plasma blackout. I should have turned off SAS. It's been a while since I have flown this, so that explosion you're hearing is actually the core section that we separated from burning up. Everything is looking good. I'm going to go ahead now and turn off SAS, let the vehicle aerodynamically become stable. Everything's looking good here for our flight. So now we'll just descend on down, get the drogues out, get the mains, land, and then we'll do one more test flight of thrust to weight ratio, maybe add some side boosters and just go through that experiment and calculation with reference to thrust to weight ratio. I think that's what we shall do. So we're coming down here very nicely. And again, this is our training vehicle Mark 1, because we will do more training missions in the future. Just go and get the drogues out. Get the mains out. So yeah, we will do future training missions of talking about several things, like delta V, like how much change of velocity do you have when you're really either launching or when you are doing orbital maneuvers. We'll do a docking, landing. So we will do training missions in the future, and this is mission 18, where we are training here about thrust to weight ratio. So there we go, nice landing. Let's go ahead and recover the vehicle. Let's do another flight here. Let's change the configuration of the vehicle. So we are going to keep our capsule. All right, so here is our simple TV Mark 1 capsule. And let's go ahead and save that. Now what we're going to do is we're going to put on just some structurally some different components. So let's go ahead and make this a short, fat little rocket. Let's go ahead and do that. Let's go ahead now and let's put on a larger tank. That is not a larger tank there. There we go. Oh, no, let's go ahead and put on this tank right here. There we go. And so now let's just guess, and let's put on here the Wolfhound. All right, and the Wolfhound at sea level has 63 units of thrust. Its thrust ASL is 63, and I just say units, right? So 63 units. More information, it does gimbal, so we do have control of it. So now let's look at our vehicle. Our vehicle right now, if we look, our vehicle has 22 units of mass. Multiply that times 10, so 22, rounded up to 23. So 23 units of mass. Multiply that times 10, that's 230 units of mass, while our Wolfhound only has 63 units of force. So the Wolfhound is not going to get us off the launch pad. So I'm going to go ahead and take the Wolfhound off, and we are going to look at then here the Skipper. The Skipper has 568 units, almost 569 units of force. So if or thrust, but which is force. So if I put that on there, so again, this engine here has got 500, and let's just call it 570. My vehicle only weighs 200, and now 230. So 23, rough round up, 23 units of mass times 10 is 230. So this engine right here is easily almost twice what I need. So what I'm going to do is I'm going to go ahead and throttle this back to roughly about, let's go ahead and call it 60% again. There's 60%. Now I'm expecting to have just a little over a thrust to weight ratio of 1, which will get me off the launch pad. Let's go ahead and calculate that. Or not calculate that, excuse me. Let's get it on the launch pad and let's launch it. And so that is what I do, some very quick calculations to kind of have an idea if a vehicle is going to get off the launch pad. And I really don't do it down to, is it a 2, is it a 1.5? I'm just looking to see if it's just a somewhat, I know that it's over 1, but not twice the thrust that I need. Somewhere above 1, but less than 2. It's really what I'm looking at. So, all right, so staging is go. Throttle is full and go. SAS is on and go. Flight we are go. T-minus 5, 4, 3, 2, 1. Ignition. And you can see nice liftoff. Reduce the thrust of our skipper engine. Same thing. Gonna go to 100 meters per second and then go ahead and start my pitch program. So, all right, 100 meters per second, coming up on 1 kilometer in altitude. Pitch program. We got that nice gimbal here on the skipper. So. Now you might be thinking, well, why are you doing something like this? Well, based on the efficiency of the engine, the amount of fuel that I can carry, will also help me then on what the change of velocity, which means what my orbit and so on, or how high I can get into space and all of that. So, but right now we're just talking about getting off the launch pad and looking at calculating thrust to weight ratio and will it even get off the launch pad? Well, that is how, over my Kerbal Kareer here for these last 17 missions, now this being our first training mission of mission 18, how I've been quite successful about at least getting off the launch pad. And of course, we do have throttle, so we can always throttle back, which I'm going to do here now in this flight. I'm going to throttle back to 1.5 Gs. There we go. Nice acceleration here. Continuing my pitch program. 22 kilometers in altitude. Continuing with our pitch program. It's like we've burnt about 60% of our fuel. Coming up on 30 kilometers in altitude. So I'm going to go ahead now do an aggressive pitch program. Just let now carry up into space and just go horizontal and just really start adding some tangential velocity here. That way I get a nice ballistic flight. So that is what I do for calculating if I can even just get off the launch pad with my thrust to weight ratio of my designs. And as you do this more and more, you will then start to understand your weight, the mass of your vehicle, therefore your weight, because mass is just your weight times 10, and then the units of sea level thrust that your engines can produce. And the more engines you have, then of course the more thrust that you can then also produce, and therefore then the more weight you can lift off the launch pad. So here we are, just nice flight here of our fat short training vehicle Mark 1. So nice ending flight here for this mission 18 about training with thrust to weight ratio, or TWR. So that is what I do here on the Xbox One Kerbal Space Program Enhanced Edition, of using the engineer report to tell me what the mass of my vehicle is, multiply that times 10 to get the weight of my vehicle at sea level, and then I can compare that to the sea level thrust of the engines I'm using and determine then if I have enough thrust to get off the launch pad. And again, I don't want excess thrust. I can always throttle back, but I really don't want excess thrust, so I try to keep it that ratio below 2, but of course greater than 1, so we can actually get off the launch pad. So let's go ahead and separate. Nice separation. Let's go ahead and rotate the vehicle into retrograde, get ready for re-entry. Go ahead and warp here. Go ahead. We'll come out of warp as soon as you can see how high we went. Look at this. Oof. We had a lot of delta V with this vehicle here. We're actually going to go, are we in orbit? No way. Well, I can't because we do not have control of the vehicle, so we're going to have to go as far. There we go. Go ahead. Do we have Oh, yeah, we did. We put antenna on here. Let's go ahead and see. I'm going to extend just one antenna here. There we go. Then the antenna, at least have a better control of our vehicle. Let's go ahead and go into retrograde. Let's look at our orbit here. You can see that. Look at that. Almost an orbit. We have flown our launch differently. We would have really had an orbit there. So we carried so much more fuel with that bigger tank and bigger engine. So alrighty, so let's go ahead and continue to warp. Go ahead and get into re-entry phase. SAS comes off. We're going to let the aerodynamics of the vehicle. There we go. Vehicle is now stabilizing due to aerodynamics. We're in 4x time warp. We might lose that antenna. We're in plasma. Yep, antenna is broken off. Right, re-entry here is looking good. Vehicle is stable aerodynamically. All right, we are out of now plasma. A warp. I still can't even put out the antenna there. No problems. All right, let's go ahead and warp on down. Flash down, and then this will conclude mission 18 here, our first training mission. Right, mains are coming out, where we have discussed thrust to weight ratio, and can we even get off the launch pad in a very simple calculation. Just take the mass of your vehicle, multiply it times 10, get the units of weight of your vehicle, then compare that to the sea level thrust of the engines that you are going to use. And if you're going to use multiple engines, just multiply by how many engines you have, or just add up, take the sum of the thrust of all of your engines to determine if it is greater than the weight of your vehicle, and you will then get off the launch pad. And of course, we have to do this here in the Xbox One Enhanced Edition because we do not have the mods to be able to calculate for us and tell us what our thrust to weight ratio is and what our delta V is, and so on. And so in a future training mission, we will talk about delta V, or the change of velocity based on the impulse of the amount of fuel that we are carrying in our vehicle. So nice splashdown. Let's go ahead and recover this vehicle. And so that is the conclusion of mission 18 of my Kerbal Kareer here on the Xbox One Enhanced Edition. This has been our first training mission where we have been discussing thrust to weight ratio, or TWR. So you know the plan. Thumbs up because you're amazing. Subscribe and chime that bell to get notified. I am Uncle Mike.